All right, everybody. Today we're going to do or I'm going to do a little demonstration for you dealing with diffusion and osmosis. So, before I start this demonstration, you might want to pull up the questions that are on the Buzz assignment. And as I'm going through this video, you can kind of pause it and answer some of the questions. Or if you just want to watch the demonstration in its entirety and then go back and answer the questions, you can do that as well. So let's kind of review a little bit of the terms diffusion and osmosis we talked about in the lecture video. Remember, this is the term diffusion. Refers to just the movement of particles. I think I mentioned this in the video the other day or yesterday. If I were to take some air freshener and just start spraying it, in my room, and just like kept my finger on the trigger and just let this stuff just go. Right up here, like where I'm at, this air freshener would be highly concentrated, right? But on the other side of the room, it's not going to be, right? But diffusion just refers to particles moving from high concentration to low concentration. So over time, it'll be less concentrated up here by my desk, and it'll be more concentrated in the back side of the room because those particles are moving to fill up the entire room. Okay, so again, diffusion, movement of particles from high to low concentration. Just remember that. It's kind of easy. Now, the term osmosis is diffusion, basically, but it only deals with water. So it's water moving from high concentration to low concentration. And again, that usually refers to our cells, because we have a lot of water on the inside of our cells, a lot of water on the outside of our cells, but there's different concentrations. So if, for example, there's more water inside your cells than there is outside, then that water is going to move out of your cells because it moves from high to low concentration. If there's more water on the outside than there is on the inside, then water is going to move in. Okay, so again, osmosis is just basically the diffusion of water. Okay. All right, now for the demonstration that we're going to do today, I've got to show you a couple of things. Um, One of them is just this little plastic baggie. Okay. Now, this little plastic bag is going to um, I guess, replicate a cell membrane. It's going to be like this is going to be like our little cell. So we know that cells are, or at least cell membranes, are permeable to some substances, right? And they're not permeable to others. So what I'm going to do with this bag is I'm simply going to pour some distilled water, into our bag. I think that's probably plenty. Okay. So you can kind of tell that this bag is not permeable to water, because if it was, the water would be coming straight through the bag. Even if I zip it up, the water's not coming out, right? So this bag is not permeable to water. Okay. Now I'm also going to put in this bag some cornstarch. Just some regular cornstarch you might find in your mom's kitchen cabinet. I'm going to pour a little bit more water in here first. That's a little bit better. So I'm going to pour a little bit of this cornstarch in. Cornstarch is kind of a white, powdery substance. Kind of looks like baking powder a little bit, but pour a little bit of that in there. That should be enough. I'm going to seal my bag. Kind of give it a little shake. I'll try to mix things up the best I can in here. Okay, so now you've just kind of got a little mixture of water and cornstarch. Okay, that's all it really is. Now I'm also going to I've got a beaker here with some distilled water in it. Okay, I'm going to set that up. I don't want to put that on my computer. And in the beaker, I'm going to put some iodine. So this is just distilled water, just water. Now iodine, once I pour it in here, you'll kind of notice that it has sort of an orangish color to it. Kind of give that a little shake and let it kind of diffuse a little bit. Okay. So there's our little iodine and water solution. Now, what's kind of interesting about iodine is it acts as what we call a chemical indicator. It actually indicates the presence of a certain substance. And that substance is starch. So, for example, like I'm just going to use this water, this leftover water that I had. I'm going to put some cornstarch into this beaker. Oops. So here we have some cornstarch and water. Now take a look at what happens to it when I pour some iodine into this beaker. Okay, so here's just a beaker with water and cornstarch. I've got a little bit of iodine here. Take a look at what happens to the color. It's kind of hard to see a little bit, but it's actually kind of a dark purple, almost a blackish color. Okay, and that color change indicates the presence of starch. Okay, so iodine is used to indicate whether or not starch is present. Now that's not really the experiment. I just wanted to show you that iodine is an indicator. Okay, so what we're going to do is we're going to take our baggie that has our starch and water in it, and we're going to place it inside of our beaker of iodine and water. And we're just going to let it sit for a while. Usually it takes maybe an hour or two. All right, so what you might want to do right now is just kind of pause the video and you can answer some of the questions. You can't answer the last couple because you haven't got to the results yet. But pause the video, maybe answer some of those questions. And I'm going to show you the results when you come back or when you unpause the video because I did this experiment this morning before I started making this video. So I already have the results already set for us. All right, so if you've unpaused the video and you've answered some of the questions, you're now ready to look at some of the results. So this is sort of the result of the experiment. So what I'm going to do is I'm going to take this bag out. I probably should have put a towel or something up here. And this is the contents of our bag. Now you'll notice that the beaker itself, the contents of the beaker haven't really changed. We still kind of have that orange color that we had before. But you'll notice that the color of the contents of the bag have changed. So I want us to think about what happened here. Okay, I've been letting this sit for about an hour and a half, about 90 minutes, and ask yourself what happened to cause this color change inside the bag, right? Think about what was in the bag to start with. Think about what was in this beaker to start with. And think about the permeability of this bag. Did this bag allow anything to pass back and forth? Is it permeable to any of the substances that we've talked about? Water, iodine, starch. Think about those three substances and which of those substances most likely got into this bag to actually cause that color change. All right, so I'm going to stop here. I'm going to let you guys go ahead and answer those questions. And hopefully you kind of understood um, what happened in this particular demonstration. All right, so take care, everybody, and hopefully I'll see you guys soon, maybe after Christmas break. All right, have a good day, guys.